Hey everyone, welcome back to my Python programming tutorials. In today's video, we're going to be talking about Dunder methods. Dunder methods, or they're sometimes referred to as magic methods in Python, are methods that start with and end with this double underscore right here. So this underscore underscore init is a Dunder method, and we've seen a couple of other ones, underscore underscore iter and underscore underscore next method. They are commonly used to overload operators such as stuff like the plus or the minus, for example, or the multiply. But there are a bunch more than just these operator overloaders, as we saw, for example, the iter and the next. And if you don't remember what these are, be sure to check out my other video that I've done on the iterators. There are a lot of these Dunder methods in Python. However, in today's lesson, we'll only focus on underscore underscore len, underscore underscore repr, underscore underscore string, underscore underscore equals, and underscore underscore add. So basically the length, the representation, the string representation, the equality, and the addition methods. So going back to the example that we had of this garage right here. If you don't remember this class, again, check out the previous video. I kind of walk through what this is and why we did it. Now, if I go ahead and create a garage object, let's say for now it's empty and there's nothing there. Why can't I just say, okay, well, what is the length of garage? How many cars are in garage? The reason I can't do that is because it's saying this object of type garage has no length. And the way that we can get rid of this error is by implementing this len function. The way we would do that in Python is by implementing the underscore underscore len Dunder method. Now the underscore underscore len Dunder method, it is an instance method. So we are trying to get the length of a specific instance, as you can see here. So that's why it is an instance method, and it will be passed the keyword self. All we want to do is we want to get the length of the cars. How many cars are in the garage? So this method is very simple to implement. All we're going to do is return the length of cars. And the way we can do that is simply by saying return len self.cars. And that's all there is to this len Dunder method. So now if I save this and I rerun it, if I go ahead and create an empty garage and then I call the length function on garage, now we could see that it's going to be giving us 0 because there are no cars. If I create a Tesla and then I add this Tesla to the garage and now I call the length function on the garage, you can see that now there is one car within this garage. So implementing this len Dunder method will let us compute the length of a certain instance, and you define what you mean by length. In this case, what we meant by length was how many cars are in the garage. So now let's go back to this Tesla class over here. If I were to log Tesla, I would get this message. And likewise, if I were to print Tesla, I would get the same ugly message over here, and pretty hard to tell what this is. All it's telling us is that this is a Tesla object at some sort of memory address. But let's say every time we printed Tesla, we would want to print I am a, and then whatever color Tesla it was. So in the case of this Tesla, it would print I am a blue Tesla. Well, that is what the underscore underscore string Dunder method is for. Again, it's an instance method because we're going to be printing a certain instance of this class. So for example, we're going to be printing this instance of the Tesla class. This underscore underscore string Dunder method needs to return us a string. So we said that we wanted to return the string I am a, and then the color of the Tesla. So in this case, I'm a blue Tesla. So there you go. I'm returning this string. Now, if you don't know what F strings are, I suggest you check them out. I didn't touch up on them, but you basically throw an F in front of here, and you can kind of think about it as formatting a string. So if you throw an F here and then you put these curly braces, in between these curly braces, you can access or put in any variable you want, and then it will format the string very nicely. So you don't have to put any placeholders or anything. You can just open these braces, put the variable name in there, and then continue on with the string. So now this underscore underscore string method is going to return us this string right here whenever we print this Tesla. And I'm going to create two separate Teslas. Now, if I print Tesla 1, you could see that it prints I am a blue Tesla, and that is because the color of Tesla 1 is blue. If I go ahead and print Tesla 2, you'll see that it prints I am a green Tesla. Again, that's this placeholder right here grabbing the color of each instance. So now we have nicely printed out a message every time this Tesla object gets printed, and we no longer see this ugly message over here. But what happens if we log either of these Teslas? If we log them, we still get the same message that we had up here. And the reason for that is there's two different things in Python. Is when we print, Python tries to run this method right here, this underscore underscore string method. And if it is implemented, well, then Python will simply print whatever you tell it to print in the underscore underscore string method. Now, if this method isn't implemented, Python will try and find the underscore underscore repr method, which is the representation method. This representation method is going to return us a string just like the underscore underscore string Dunder method. But let's say for here, I want a different representation whenever we want to log it. So I want to log it the same way that the constructor looks. So the way we can do that is by saying Tesla, and then we would include this brace. In here, we would put the color. So in this case, it's self.color. And then we would create this tuple of all the X, Y, and Z coordinates. I apologize, the string is pretty long, but it is going to look just like the constructor. So we're going to have the color over here, and then we're going to have a tuple of the positional coordinates. So the X value, the Y value, and the Z value. I've created this Tesla right here that is blue, and it's at position 1, 2, 3. So now if I print this Tesla, Python will first look for the string Dunder method right here. And because it's implemented, it will print this. So if I run this, you could see that it prints I am a blue Tesla, which is what we have in the string method. However, when I log it, now it will print us exactly how the constructor looked like when we created this Tesla object right here. So again, logging it, Python will look for the representation Dunder method, but printing it, Python will look for the string Dunder method. If the string Dunder method isn't available, so if I delete this code right here, I create this Tesla. If I try and log this Tesla, you'll see that it calls the repr method. But if I print it, you will notice that it uses the repr Dunder method too. So again, for printing, it tries to find the string method, which is this one. However, if it doesn't find this one, then it turns to the repr method. If it doesn't find either of these, then it gives us this ugly representation over here for both print and representation. Now let's go back to the garage example and let's see how we can add two garages together. So let's say that at any point, two garages can kind of merge together. And what that means is that we would create this other garage that will have the contents of both of the garages that got merged. So let's say we have this first garage that contains just the Tesla, and then we have this second garage that contains just the Nissan. If we were to try and add these two garages, for now, we won't be able to because it's saying unsupported operand, the plus right here. So this plus is unimplemented for this type garage. What we want to do is if we add these two garages, then we want to be able to create a third garage that would contain both the Tesla and the Nissan. So the way we can do that in Python, you can probably guess it's by implementing the underscore underscore add Dunder method. Now this underscore underscore add method, it is a instance method, meaning it will need to access the instance variables. However, it is also going to intake another parameter which we usually call other. So the first parameter that we have to a plus sign is going to be the instance itself, and then the other parameter is going to be the other thing that we're trying to add to it. So in the case of this line, gr1 is going to be self and gr2 is going to be other. And so for this add method, what we want to do, we said we wanted to return a new warehouse that contains both of these cars. So what we can do is we can say return, and we can create a new garage object. And again, you can do that by calling the constructor, and the garage constructor requires a parameter of cars. If we want to combine the cars, we're going to need to access the self instances cars by saying self.cars, and then we're going to want to add on to that others cars. And we can leverage that Python supports list addition because self.cars is going to be a list and other.cars is also going to be a list. So if we add those two lists together, we'll get a third list, and then that entire list will get passed into the constructor of this new garage object, and then it will be returned. So now if I go ahead and I create this Tesla and this Nissan, and then I create these two separate garages. So garage 1 is going to hold the Tesla and garage 2 is going to hold the Nissan. Now if I say gr3, so garage 3, I can set that equal to gr1 plus gr2. Now you can see that this code doesn't error out. And if I go ahead and iterate over gr3, you could see that we have this Tesla in here and we also have this Nissan in here, meaning it's a combination of gr1 and gr2. Again, the reason this is printing is because the str Dunder method is implemented for the Tesla, however, it's not implemented for the Nissan. The last method we're going to talk about is the equals method, and it's to check for equality. For this example, we're going to say that two garages are equal to each other if they have the same exact cars in them. Now, again, in order to implement this equality, we would need to implement the __ equal Dunder method. Now this __ equal method is just like the plus. So the left side is going to be one parameter and the right side is going to be the other parameter. Like we do when we say like 1 = 1, this is going to be the self parameter that we pass here. And then the object on the right of the operator is going to be the other parameter. So that's why we define this __ equal Dunder method with the self and other, because we want to compare the current instance to the other instance. And like we said, two garages are equal if they have the same cars in it. So all we can say is just return if self.cars is equal to other.cars. So I've gone ahead and created 3 cars, Tesla 1, Tesla 2, and Nissan. I can go ahead and create a first garage, which is just going to contain Tesla 1. And I'm going to create a second garage, which holds the second Tesla. If I apply the double equals operator, saying is GR1 equal to GR2, meaning garage 1 is equal to garage 2, we can see that it's not. Even though they both contain Teslas, these are different Teslas, so they were not going to be equal to each other. Obviously, if we wanted them to be equal to each other, we would have to implement that within our code. However, for now, we're just going to keep it very, very simple, and we're just going to make sure that it's the same object within these 2 arrays. If I go ahead and create a GR3, which holds a Tesla 1, now if I do GR1 and see if it's equal to GR3, now we're going to get true because GR1 holds a Tesla 1 and GR3 holds a Tesla 1 too. As you can probably tell, if I create a 4th garage which holds the Nissan, and then I check if any of these garages are equal to garage 4, it will always be false because no garage holds the Nissan. So there's the first garage, here's the second garage, and there is the 3rd garage, right? So that's it for this tutorial on Dunder methods. Hopefully you've learned about the use cases of these Dunder methods and how you can implement them in your own code. If the videos helped you out at all, please like and comment as to what I helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. I've also included links to my Instagram and Twitter down below. I'm going to be posting on there whenever I post a video on YouTube to help you stay notified. And yeah, that's it. I will catch you guys in another video.